Hey everyone. Happy equinox to everyone. Today is the day where Earth is perfectly aligned in its orbit and with its tilt, such that there is an equal amount of light and dark on the planet. So, we have 12 hours of daylight and 12 hours of night. In the northern hemisphere, there will be less and less light and more darkness, and in the southern hemisphere, the light is rising. This has historically and traditionally been known as a very powerful, energetic portal or just a very powerful energetic day. A lot of different celebrations and traditions were done and are still being done on the equinox. Well, we are having an energy explosion right now across the globe. Multiple powerful storms are swirling around in Earth's oceans. We have violent typhoon Ragasa, equivalent to a Category 5 hurricane. This is the strongest cyclone yet in 2025, soon to make landfall near Hong Kong, sweeping right now in between the Philippines and Taiwan. In fact, there was just a magnitude 4 earthquake right in that zone, seemingly set off by this violent typhoon. We also have Category 4 Hurricane Gabrielle now in the Atlantic that rapidly intensified to a Category 4. We also today had a magnitude 4.3 earthquake in Berkeley, California, right near the Hayward Fault. California is a very earthquake-prone area, though there haven't been that many earthquakes there of significance lately. We've been having all these big earthquakes elsewhere across the globe, specifically in Kamchatka near Russia, and well, maybe that is loading energy into the California section of the Ring of Fire. That's very interesting, and maybe this is a foreshock to something bigger. The USCS is saying that this is the complete earthquake sequence. There's been some activity there now for more than a few days, but we don't know, it could be a foreshock to a magnitude 5 or greater. We also have a fast solar wind impact right now. So on top of all this, our space weather conditions are in flux. It is changing. We have gone from quiet geomagnetic conditions to more active geomagnetic conditions as this large coronal hole has rotated into the geoeffective position, and that high-speed stream of solar wind which flows out of that structure sweeps by the Earth. Let us check out, first off, the biggest storm yet of 2025. This is Typhoon Ragasa. Just an absolute monster here. And so we see that it is barreling right now towards mainland China, so the eastern coast of Eurasia. It did manage to slip basically in between Taiwan and also the Philippines. It's expected to pass just a little bit outside of Hong Kong, but massive winds. Here we have our climate reanalyzer. This is a very useful website for looking at things like temperature anomalies and sea surface temperature anomalies. You'll see our legend here, and this is in Celsius or centigrade. So this is different than Fahrenheit, meaning that if you get up into these color ranges here, that brown and even that red, this is very serious. We see some significant sea surface temperature anomalies here. Now, in fall, it's no longer summer in the northern hemisphere. Now it is fall or spring for the southern hemisphere. But for the northern hemisphere, for fall, look at all these super intense temperatures. We see some up here in the Arctic Ocean near Russia. We can see some of the sea surface temperature for the Pacific that is highly anomalous. We also have some around here in like Maine and Newfoundland and more. And it's not the only zone. It's the primary zone though. We also have a lot of sea surface temperatures there in the Mediterranean. There again is the, like, Northern Europe right there. You can see that that's quite intense. Actually, some of the most intense sea surface temperature anomalies measured in the globe right now. Look at how intense it is around the Western Pacific, Japan, Philippines, Taiwan, Korea, or China. All this area is undergoing extreme heat flux, at least as it relates to the ocean. And so that is feeding tropical typhoon Ragasa to these violent levels, equivalent to a Category 5, with a huge eye wall, super low pressure in that, like about 900 millibars. The other one is Hurricane Gabrielle right now. This is now a Category 4, rapidly strengthened. It was not a Category 4 all that long ago. It's not expected to make landfall for the United States. Right now, it's basically moving north through the North Atlantic, passing close to Bermuda. But this is a very, very powerful hurricane that we have active. We can see this may go to Category 5. I wouldn't be surprised because of the space weather impact. If we zoom out, we see the expected path for this hurricane here has just recently really formed up. Not that long ago, it was just like a disturbance, basically, and then went from Category 1 to Category 4 incredibly quickly. I mean that's in basically 24 hours. It went from Category 1 to Category 4, which is not unheard of, but still a sign of the type of world that we're moving into in this day and age, one where there's just more extreme energy volatility. Zoom Earth also has a zoom here on Ragasa. This was a super typhoon not too long ago, and now it is a violent typhoon, which is the highest category, effectively a category 5. The sustained wind speeds are 114th. Sorry, I got that wrong, actually. Super typhoons are stronger. If you look here, it was 165 sustained wind right there. The pressure went down to 910 millibars, and now it's a violent typhoon. It did just go through its peak, and now it seems to be coming down a little bit, but still very, very strong. Hong Kong is right there. Guangzhou is just a little bit further in. It's going to cut right over, not North Korea. It looks like based off of the current trajectory. The Philippines has been hit hard. Lots of rain to Taiwan as a result of this, but nothing super violent because it did stick closer to the Philippines. But if it maintains any sort of strength as it makes landfall, this could be very intense. And this, I believe, is the first big storm to make landfall in 2025 in a significant way. One of the other big things that happened today is that we had an earthquake in Berkeley. Look at this. Before we do that, here we have this 4.6 earthquake there in the Philippines. Wait, isn't that basically exactly right where Typhoon Ragasa passed over? Yes, it did. And so, this occurred just recently. If we go set this for universal time, we see that was at 2033 universal time. So just a few hours ago, right as the bulk of this typhoon was over that area, the Luzon Strait. That's a clear example of a stormquake where you get these intense atmospheric disturbances. They're generating a bunch of electromagnetic energy and also these gravity waves, and that can cause faults that are at their critical stress to slip, release, and to produce an earthquake. We've seen this time and time again. They're usually not the biggest quakes, like magnitude 4. Magnitude 5 would be kind of like up in that higher range. 4.6, though, is nothing to just discount. That can be a big earthquake depending on the local conditions. And well, we just had here in California something pretty close to that. We had a magnitude 4.3, and so this was at 956 universal time, and that was at basically 300 in the morning. So it was an early morning shaker. And right here, basically right on the University of California, Berkeley. So this whole area got a good, quick jolt. 4.3 is not the biggest, but it's enough to definitely notice it unless you're really spaced out, or maybe if you're walking around. Sometimes if you're actively walking around, you won't feel it, but if you're kind of stationary, and especially if you're in a building, you will feel that for sure. And people felt that all the way down into the peninsula, San Mateo. Some people woke up from it. It's kind of a good thing that it was early in the morning in terms of a test, because if you're in a really deep sleep, you'll sleep through it. But some people, light sleepers, because they are completely still and calm and quiet and it's not busy outside, there's no big 18-wheelers driving by, it basically presents itself as a very novel stimulus. So, a 4.3 earthquake for Berkeley. And the question that a lot of people have anytime there's an earthquake in the Bay Area is, when's the next one going to be? Because the last big earthquake was down in the Santa Cruz Mountains, Loma Prieta, 1989, magnitude 6.9. And well, this whole area is overdue. Now it appears that this was a bit of an earthquake sequence. So we have the other earthquakes that USCS has identified as being part of this loaded into the map here, and we'll see that the oldest quakes go back to the very end of August, with this 1.2 there. And then August 30th, the 31st, then we have the 5th of September, then going all the way up to 4.3. That's today, the 22nd. And then 2.2, 2.6, and a smaller 0.9 magnitude quake. But in general, a little bit of earthquake activity clearly along the Hayward Fault, which runs right through this area, super developed. And the USCS estimates that there's a very high percentage that it's going to rupture in the next 30 years, like 75+%. That the damage could be definitely in the billions. I mean, we hopefully not beyond billions and billions, but the infrastructure damage would be really insane if we had a magnitude 7 there. And that's certainly possible. Even magnitude 7.5 is possible, though that would be probably the exact upper limit for the Hayward Fault. And it would be devastating for a lot of people there as well. But thankfully, usually the rule of thumb is, the more developed an area is infrastructure-wise, the fewer deaths there are, but the greater the infrastructure toll is in terms of a monetary cost. But is that a foreshock? That's a good question. It could be that we could be looking at a magnitude 5 earthquake in that area sooner rather than later. Down here in San Diego, we had a 5.2 recently. I felt that was up in Julian, which is in the mountains fairly close by. So it's not impossible for California to get earthquakes. In fact, it's well known for its earthquakes, though there are places that are more seismically active, Mexico being one of them. In fact, we just today had a magnitude 4.5 in Mexico. We also are having this weird earthquake swarm in Nevada nearby. So, maybe these are kind of feeding energy into that area. So, Mexico is very, very active. Also, you have Cascadia there, which can produce a magnitude 9. So California is in between these two really, really big areas, though Cascadia is often asleep until the dragon awakens and Mexico is rumbling quite frequently. This is our space weather. Here we have our real, I'm solar wind, and we are right now in a coronal hole high-speed stream impact. We do see that we had this co-rotating interaction region impact come in, going up to about 18 nanoteslers. The normal strength for the magnetic field, the interplanetary magnetic field, is 5 nanoteslers. And see here, the velocity of the solar wind did increase, and so now it's up to about 500 or so. So it has been going up. Plasma density has gone down. Now it's below 1, meaning that we are in an earthquake watch by my count. My standards is that when we have the solar wind density go below 1, it seems that we get the biggest earthquakes to pop off during that or shortly afterward. And they are also connected to these coronal holes quite closely. You can see that if we look at our SUVI imagery here, we'll see this coronal hole on the sun. This is the past 3 hours of imagery, as I'm recording this. And so we see it rotating now out of view. And we have a lot of sunspots on the sun right now. All these bright regions are sunspots. And so we have about 165 sunspots on the sun. And the biggest one right now, in fact, is exactly Earth-center direct, though our solar flare activity has been quite low over the past, well, really over the past few weeks. We haven't had an last flare now for a while. So no big massive boom shakalakas from the sun as it relates to solar flares, but we've had a lot of these coronal hole high-speed stream impacts. In fact, the one right before this, which was a little bit more aligned along the equator, gave us a G3 geomagnetic storm with like 15 hours or 18 hours of gone storming. So that was very, very significant. So that is what is happening. This big energy explosion right now on Earth, the equinox energy explosion,